What are tape diagrams and how do they help us? So tape diagrams, sometimes people call them strip diagrams, can be used to solve many types of problems, including percent problems, as well as applications of percents. You may have used tape diagrams in the past, and here's a little short video if you want to watch it that explains tape diagrams. Applications of tape diagrams. A lot of you might not be used to using tape diagrams or illustrations to solve problems. Really try to use this method since this is the method that they use in elementary school. So a lot of you may in the past have used algebraic techniques and this might not be familiar to you. So that's why we want to practice these new problems. And you want to have a well-defined and labeled tape diagram for each problem. So there's the 4 problems. 30 is what percent of 75, 120 is what percent of 200, 45 is what percent of 50, and what percent of 20 is 15. Think about those problems and see how you would do it using a tape diagram. So 30 is what percent of 75. The first thing I did was draw a rectangle to represent the entire unit, which was 75. And I labeled on the top 0 to 75 and on the bottom 0 to 100%. And I had to think about how I would see this 30, and it wasn't necessarily the first thing that came to my mind, but I thought, oh, I know how to split things into 10% pretty easily. So if I split it into 10 equal sections, then 10% of 75 would be 7 and 5/10. So I labeled each box 7 and 5/10, and then I just counted on the top with a number line. So 7 and 5/10, then 15, then 22.5, and then I got up to 30. And then I knew that 30 was equivalent to 40% on my tape diagram. So 30 is 40% of 75. And if I think logically, that should make sense because half of 75 would be what? Well, half of 70 is 35, and then half of 5 is 2.5. So that's 37.5. So 50% of 75 would be 37.5. So I knew it should be less than 37.5. So 120 is what percent of 200? Again, I drew my rectangle to represent the whole unit. I labeled 200 at the end, and then on the bottom I labeled 100%. Again, I broke it down into 10 equal pieces because if I count by 20s, I know, because 10% of 200 is 20, then I can count by 20s and I will definitely see 120. And when I do that, labeling clearly, I see that 120 is 60%. So 120 is 60% of 200. Again, if I'm using estimation techniques, I know that 50% of 200 is 100, so it should be greater than 50%. So my answer of 60% is reasonable. 45 is what percent of 50? Again, you see the technique is very similar through all of them. That's another reason that students like this. So I drew my rectangle to represent 50. On the bottom, I see 100. Well, what's interesting is I might see a proportional relationship here and say, oh, to get from 50 to 100, I just doubled it. So maybe that holds true. If I double 45, that will tell me the percentage. And it does actually work out that way, but I broke it down just like I did before into 10% sections. And when I got to 45, I noticed that that was 90%. And you could think proportional reasoning or equivalent fractions here as well, and those strategies work. We just wanted to look at this visually. One more. What percent of 20 is 15? This time, notice that I did not break it down into 10 sections. Since my number was 20 and I can tell where 15 would be compared to 20, I thought, oh, if I just counted by fives, that would work out better on this problem. And I know that there's 4 sections or 4 groups of 5 in 20. So this time I broke it down into quarters, or 25%, 50%, and 75%. And I know that 15 is 75% of 20. So I hope you continue to try tape diagrams visually. Let's look at an application problem that's a little more challenging. So Nancy got a 5% raise last year. Her current salary is $44,100. What was her salary last year? Be sure to use a tape diagram and label it thoroughly. So you have to be careful on these problems because some people have a strategy that is mathematically invalid. And I hope you catch it and see why. Pause the video here, come up with your solution using a tape diagram, and then proceed in the video. So, did you get that last year's salary was $42,000? If you used that flawed technique that I was talking about, you might not have gotten that. If you try to take 5% of 44,100 and subtract, you will not get the answer of 42,000. And if you think about that, that should make sense to you because you're taking 5% of a larger value, so you won't end up with the correct last year's salary. So again, I drew a tape diagram. Notice that I made my entire rectangle represent the current salary, which included the 5% raise. So I labeled the end of the bar this time as 105%. Then when I labeled to 100%, that would be last year's salary. Then I broke it up into 20 sections. There's 20 from 0 to 100, and then there's one more. And the reason I did that was then I could see that 5%. And so if I divide this 44,100 by all 21 of these sections to figure out what each section is worth, each section is worth $2,100. So now if I take 44,100, which is the current salary, and I subtract $2,100, I end up with the correct amount of $42,000 for last year's salary. So make sure you review this and try this on your own. You can verify it with algebra or a proportion if you choose. This problem is often done wrong no matter what strategy is used. That's why I wanted to show you it in a picture. So application problems can vary a lot. Here's a link right here to some visuals with tape diagrams that are used in middle school. It's a great strategy and it might help you a little more to understand how to do these visuals. Hope this helped you understand tape diagrams.